So this is the same type of problem, but it presents the information a little bit differently. If you remember the notes that I gave you at the beginning, we have to determine what quadrant we're in, and we're going to use the Pythagorean theorem to do this. So you look, first of all, at the trig function that I gave you. And since it's negative, and I'm going to list out the quadrants. This could be in quadrant 1, 2, 3, or 4. So this is a list of the possible quadrants that we could be in. Okay, so it could be 1, 2, 3, or 4. Since the given trig function is negative, okay, the tangent we know is positive, and negative. And like I said, the reference angle videos walk you through how to do and determine the positive nature of the quadrants. So since tangent is negative, we know that we cannot be in the first quadrant and we cannot be in the third quadrant. So we're not in the first or the third. Here it says sine is greater than 0. So if sine of theta is greater than 0, we know that sine is positive in quadrants 1 and 2. So if sine has to be greater than 0, sine has to be positive, we know that we can't be in quadrants 3 or 4. So I'm going to cross off 3 again and 4. There's only one remaining quadrant, and that's quadrant 2. Okay? So now we know that when we draw our picture, we need to draw this angle in quadrant 2. So there's my triangle. Make sure that you have the right angle on the x-axis. Okay, you always want to draw the right angle to the x-axis. So that's how we determine the quadrants. That's the first step. The second step is to use the trig ratio and the Pythagorean theorem to find the missing value. So the trig ratio gives us two values. Since tangent of theta is equal to 1/3, and I'm not going to worry about the negative sign anymore. I've used it for right now in the problem. Tangent of theta is equal to 1/3. I know that my definition for tangent is y over x. Okay, so I know that y equals 1 and x equals 3. So I can put 1 and 3 on my triangle. Since I'm missing r, I have to use the Pythagorean theorem, which is x squared plus y squared equals r squared. X is going to be 1, or I'm sorry, x is 3 squared, y is 1 squared, and then I have r. So this is going to equal 10 equals r squared, and I have the square root of 10 equals r. And we're going to worry about our signs at the end of the problem. So now I know that r is equal to the square root of 10. And I've done everything I need to do, and the next step is to actually write my trig ratios and simplify them. So in this question, I know that sine of theta is equal to, and remember sine is y over r, so y is going to be 1, and r is the square root of 10. But we can't have a radical in the denominator, so we have to rationalize it, which means you multiply by whatever the square root is in the denominator. So 1 times the square root of 10 is the square root of 10, and the square root of 10 times the square root of 10 is 10. You might need to watch that again if you didn't quite get it. The cosine of theta, the definition of cosine is x over r. So x is 3, and r is the square root of 10. But once again, we can't have a radical in the denominator. So my answer becomes 3 square roots of 10 over 10. Then I have tangent of theta. Tangent of theta, tangent is y over x, so tangent is 1/3. And that confirms what we got, and we're going to come back and put our signs in the problem in a second. I'm going to have to do the other ones up here. Now I need cosecant. Cosecant is the reciprocal of sine, and it is r over y. So r is the square root of 10, and y is 1, which that would just be the square root of 10. Secant of theta is equal to x over y. X is 3, and y is 1, so that's just going to be 3. And then I have cotangent of theta. Cotangent of theta is x over y. I'm sorry, this last one should be x over r, but I did it right in the question. No, I didn't. I'm gonna fix it in the next video, so just watch this again if you need to. This is not right, so we'll do this again. But watch the next video and I'll pick it up from here.